Hi, this is Mr. Miller. Welcome to video number 27, Introduction to the Normal Curve. I'm all alone this time. Mr. Lewis is home already and his jammies relaxing. But that's okay. We'll take care of business here. We want to calculate some percentages from histograms, and we kind of want to introduce the normal curve that way. So here we have a histogram. I'm going to do it the usual way for the first part, then we're going to switch to a different way. So in part A, it says use the counts to calculate the percent of data that is in between 5 and 18. Okay, so we see that 5 and 18, there are, between 5 and 18, there are 5 that are between 5 and 10, and 8 that are between 10 and 15. So in between 5 and 15, there are 13 values. And if we add up all the values on top of the bars, we see that there are 22 total data items. So 13 out of 22 are in the interval from 5 to 15. And if we convert that to a percent, that's 59%. So this is kind of the more usual way of doing it, just using the totals from the top of the bars and calculating percent. We want to switch to the idea of using area, though. So I'm going to answer the same question with area. If I want to know what percent of the data is in between 5 and 15, that's equal to the percent of the area that is in between 5 and 15. So I want to start thinking area. So the area of this first bar, well, the width is 5 and the height is 5. So this first bar has area 25. This second bar also has width 5 and height 8. So the area is 40. So the total area there in those two bars is 65. We want to divide that by the total area. So, well, I got to find the total area. The area of this bar I haven't found so far is 15. This one is 20. And this one is 10. So the total area is the 65 I had already. That would make 95, 100, 110. Okay, so 65 out of 110, and it should give me the same percent. So I'm dividing it on my calculator here. 65 divided by 110, sure enough, 59%. I want to think about these percents in terms of area because that's how distributions work, and the density curves, which the normal curve is one of. All right, the next one should be easier. Use the area to calculate the percent that is 15 or greater. Excuse me. So 15 or greater, well, the area that is under that part, for the parts of data that's 15 or greater, is 20 plus 10. So that area is 30, and still out of a total of 110. So it was this bar right here and that bar right there. Those correspond to data values greater than 15. Okay, so 30 divided by 110 ends up being 27%. Okay, one more using this graph. It says use the area to compute the percent of data that is less than 10. Less than 10 would be this bar and this bar. So the area that corresponds to the part less than 10 are these first two bars. So 15 plus 25 is 40, divided by the total area, and we get 36.4%, or about 36%. So again, if we want to know the percent of data that lies between two values, it's the percent of area that lies between those two values. Here's another example. So we use the area to calculate the percent of data that's between 20 and 50. I'm going to really quickly kind of label the area of the bars. So now that I kind of know how this works, that'll help us. So this first one is 10. This one is 10. This area is 20. This area is 30. This one is 50. This area is 70. This one area, the width is 10, the height's 3. This would be 30. This would be 20. This would be 20, and this will be 10. So now that I labeled the area of each of the bars, we can go quickly. So use the area to calculate the percent of data that is in between 20 and 50. In between 20 and 50, the area is 20 plus 30 is 50 plus 50 is 100. That's the area of the 3 bars that have data between 20 and 50. And we got to divide that by the total. 10, 20, 40, 70. That'd be 120, 190, 220, 240, 260, 270. I get as the total. So 100 divided by 270 is 37%. 37% of the data, let me write that clearly, 37% of the data is in between 20 and 50. Okay, use the area to calculate the percent of data that is less than 30. Okay, that's these 3 bars right here. It'd be 10, 10, and 20. That's 40. And the total is 270. So 40 divided by 270 is about 15%. Okay, last one. Use the area to compute the percent of the data that is greater than or equal to 80. So that would be these 2 bars over here. Their area is 30 out of the total area. And those 2 bars represent 11% of the area. So 11% of the data is there. Okay, so the main idea we're trying to emphasize here is that the percent of data that lies between 2 values, let's say like 20 and 40. So the percent of data that lies between these 2 values is equal to the percent of area that lies between those 2 values. Okay, so if I can find that area divided by the total, that's the percent of data that lies in between there. Okay, so we're ready to start something big here, and it's going to take a day or two to kind of wrap our minds around the whole thing, but let's just get a little introduction today. So welcome to the normal curve. So the normal curve is a curve that's used to approximate data, and I have a cool little app here that's going to help illustrate this for us. So it said based on a normal model, N, that stands for the normal model, with 116. The 100 part is the mean. So let me get my pen back. So the 100 is the mean right here. Ah, I forgot. I can't have my pen and this at the same time. So 100 is the mean, and the standard deviation is the 16. So I'll adjust the curve in a minute, but this is used to describe IQ scores. And we want to find what percent of people's IQ you would expect to be over 80, under 90, and between 112 and 132. Okay, so there are a lot of different normal curves. This one's set to have a mean 0 and a standard deviation 1. But I can change that. So it has mean 100 and standard deviation 16. And I kind of changed the curve. There we go. So there's a different curve, normal curve, for every mean and standard deviation we can think of. Okay, kind of like what we're doing in the histogram. If I want to know what percent of people have an IQ over 80, I got to find the percent of the area that is above 80. So I'm going to move the slider to 80, and I'm going to move this one all the way. This actually goes on forever. So if I want the percent of people who have IQ over 80, I got to find the percent of area that is above 80. And this calculator does it for me. This value down here I'm pointing at, 0.8928, is the percent of people who have an IQ from about 80 and above. So let me see if I can get my pen working. Come on, pen. So over 80 would be, there it is, 89%. This is kind of hard, but we'll get it working. All right, let's answer the next question. So it says under 90. So I got to find the percent of area that's under 90. So 90 is about right there. That's pretty close. So the total area of the curve, by the way, is 1. And this area that's shaded is 0.2685. So since the total area is 1, I just got to find this area. So the area is 2685, that means 26.85% of the data is less than 90. Okay, so let me record that again. So about 27% of IQs under 90. All right, between 112 and 132. So again, if we want to know the percent of IQs in between 112 and 132, we got to find the area between 112 and 132. And I'm just going to type it in now instead of trying to use the sliders. So this will be a little bit more exact, 112 and 132. And I press enter. And sure enough, the area in between 112 and 132 is 0.2039. The total area is 1. So if I do 0.2039 divided by 1, I get 20.39%. All right, so 23.9%, or about 20%. So the basic idea I want you to get is that we have a normal curve. It's going to be really hard to draw with a pen. It's very slanted. Sorry about that. But the center value is the mean, and that's 100. And in order to tell what percent of the data is in between two values, we just find the area that's in between those two values. That's kind of cool. So any two values we pick, as long as we can find the area between them, we can tell what percent of the data is in between those values. And that's kind of what we just did. Another example here. So again, this time we have cholesterol levels of adult American women can be described by a normal model with a mean of 188 milligrams per deciliter and a standard deviation of 24. So they're telling me that we can approximate the data with a normal curve. So this time our mean is going to be 188. And our standard deviation is going to be 24. Okay, now the model is adjusted, and we see that the curve is centered over 188. And we'll talk about where the standard deviation is in the curve in a day or so. So they want to know what percent of adult women do you expect to have cholesterol levels over 200 milligrams? Okay, so we want to set the lower limit to 200. So we'll move the slider this time. I'll set it to about 200. And above 200, so we want all the area under the curve that goes from 200 and above. And we see it's about 30%. 30% of the area is right there. So 30% of the American women have cholesterol levels above 200. So let's record our 30%. What percent of adult women would you expect to have cholesterol levels between 150 and 170? Okay, so let's move the sliders between 150 and 170. So let's see how much area we have between 150 and 170. That's about it there. Looks like about 17%. 0.1703 is that area. Since it's out of 1, that's 17.03%. So let me record that. So 17%. Okay, so we're going to learn in class how to use our calculator to make these normal curve approximations. So there's a lot of mysterious things here, and I don't understand like what is going on. The main idea is that we have this curve. And the area under the curve tells us the percent of data that's in a certain range. Okay, and we'll be doing a lot more of this in class. Okay, it's time for our journal assignment. So use the area to calculate the percent of data that is between 8 and 24. Okay, so find out first what the area of each bar is. The width of each bar is 8, then multiply it by the height. So the area of this first bar is 16. Find the area of the remaining bars and use area to calculate the percent of data that's between 8 and 24. For number 2, use the area to calculate the percent of the data that is less than 16. And for number 3, use the area to compute the percent of data that is greater than or equal to 32. All right, thanks for hanging in there. We'll talk about normal curves in class. And you guys are going to be normal curve experts in just a couple of days. See you later.